Hello. Thank you very much. And
喂，你錄咗後邊啊？
轉咗反佢。
邊個嚟反啊？
得啦。Yeah, so I have a live stream for the. Let me scan the QR code. For today's, I also represent the DeepLearning.AI here to share the Thailand AI talk. So if you scan the QR code and then attend the event, just register, I will set you attending, and then you will get a discount voucher to join the DeepLearning.AI for their course for 1 month subscription, as I know is that. Okay, you can keep scanning the QR code as every page the QR code will be here. And it's me, and you see, actually I'm machine learning hero here, and Microsoft MVP, and Google developer expert. All of them is around the cloud technology. And I've been teaching cloud computing for many years, and I believe I am the strongest educator in teaching cloud computing on the ground. And also, if you like to learn some technology in Cantonese, you can follow my YouTube channel, and sometimes you speak English, sometimes in Cantonese. And I will not be appear in all the talk all the time. It depends on I want to speak. And today I will be talking about the large language model and then prompt engineering major, and then LangChain, but don't have time to speak too many languages, just a simple example. Basically, understand LLM, understand a general language, just natural language, human language, for your program. And even from a lot of data on the ground, and it's able to do anything you know or you don't know, just try it. Okay? And basically, you need to know about the term so-called foundation model. It is just a very, very large neural network, and a lot of nodes, a lot of layers, and it ingests a lot of data, and then it is able to do multiple tasks. It's very different. In the past, you say, a few years ago, people talking about the different type of LLM is a scoper, and then to classification is very small. Compared with GPT speed, not talking about 3.5 or 4, the size is very, very different. But now it's more like even bigger. The logic of working on large language is that the first step is so-called tokenization. LLM understand what the language is not like us in the rest. It will try to split the rest, not follow the rule of English, and then go to the model, and it will try to best use of probability to generate the output for you. And then you will have some processing in general from current. For example, it will prompt you from asking we done something not good for you. And here is that every time you put a sentence there, it will tokenize Kapila, but it is not actually follow the rule of English, and then show you the next token. It's an auto-complete, just an auto-complete. Here's one of the examples. Is over token. You see the token here of just one English word, but it is not follow anything about the grammar. It is based on probability to generate the token. And if you understand their logic tokenization, you can try ask some very simple question to all LLM. It will not able to reverse a sentence. ABCD. If ask it reverse, it will never work. And in behind the scene, this is a token. The token is different. And for auto-complete, you will see this is something so-called regressive. It will give the previous result, put the new result again. That is the reason why LLM need to use a lot of computational power. It is an iteration recursive grouping. Okay? If you understand this logic, I can tell you the prompt engineering is based on the design. Here is the animation. You put a keyword generate, it feeds it back to the LLM and then get extra output. And it is a probability. Okay, just a probability. Auto-complete. That's all. All the LLM is doing auto-complete. They never answer your question. They never know what they are doing. They just try to auto-complete. Okay, but you put in a question, it auto-complete is an answer, just that. And based on the probability, and mainly for the people who are using LLM in general properly, or you are not IT guy, you will just think about ask the question and then get an answer. But actually, behind the scenes, another very important properties of LLM is that it is able to help you to convert your sentence into a series or number. We will so-called embedded, a vector, to train the representation on top of the meaning instead of the word, the wording, language. It doesn't care. It cares about the meaning. And it is very, very important part on using LLM. It's semantic similarity. But a lot of people don't know this one. In between, you have RAG, also in between, you got the problem hallucination. And in summary, you can do it like a chatbot, but test in, test out, test in, work out. LLM feature, mainly work in, work out, test in, work out. Okay, this is a graph to tell you what's embedded. You just input different language, different sentence into the embedded model. It will convert it into a high-dimensional vector, say 200 something, 1,000 something, a very long number, a serious number. And then you can try to draw the vector into a graph, but it will be balanced. You will just do something, principal component analysis to map into 2D. You will find something very interesting. You input a language there, even based on the meaning to set the position of the vector. So we can do something very interesting on top of these properties. And here's something new technology very popular, the vector database. Vector database is that you input the text and then it will convert it into vector, okay, and then save into the database. When a question coming out through the online one, input times, you send the question into the model again, and then become a vector. The vector maybe based on the similarity and the distance, okay, the distance between the vector to take out the similar context, the answer for you, the data for you. This is the core idea of the current usage of LLM. Okay, now it's going to the prompt engineering, and I believe a lot of differentiation, but this one is the best one for you. It is a programming language, okay, but in English. That is a way to make your LLM to grow instruction, something like writing Python, writing C#, writing Java, but in English. It gives you back your answer. Don't need to train it. This is the reason why LLM is so popular. You don't need to waste time on training. Okay? For example, you just input the sky is, and then it just autocomplete. Okay? It's not special. Every autocomplete. But there is some very important parameter I need to explain to you today. Okay, in general, it's something general, not for one model. In general, the explanation is very similar. And when you write a prompt, you need to decompose your prompts in different structure. Okay, in general, you will have instruction. You may not have context. You may not have input data. But normally, you expect to ask for the output. What kind of output is that? This is requirement. Some people will have more section, but this is good enough. And keep in mind, you normally need to set up two parameters, so-called temperature, topic, okay. And if you want to have something not random, okay, just predictable, you set the lower temperature. If you want to do something very creativity, you set high temperature. Let me so explain those parameters for you, but this diagram is better. Everything is probability, okay? Next one, based on the probability to take the log, okay, to take the next path. But you don't want it always take the same path, otherwise it don't have creativity. Okay? Here is the one of the parameters, so temperature. Okay. Before we talk about temperature, it's something called softmax later, is something analytical, but you don't have to care about, don't have to care the detail. In general, you just know the problem, don't know the feature and how to set it. You can tune the temperature temperature with an extra parameter on the formula, but this is the output. You just know about the output, okay? When you set a temperature is nothing, don't have temperature, there will be a sub distribution on the next row, okay, the next row. This is a probability. But you don't want to have so many randomness. You want to have a unique answer. You set the temperature to 0, then it will go only provide you the highest probability single answer for you. So you can test it. Every LLM, when you set the temperature to 0, you ask the same question, got the same answer. Okay, this is something happen. So if you do the application, it's a fact check. It's about database, your record. You will always set the temperature to 0. You don't have to worry about set 0. But if you try to change the temperature, you see the distribution become flatter. And when it's flatter, it is possible to have more output, more next word possibility will come out. But for the selection, you understand that if we always take the highest probability, the answer will be always only one answer. So we will have a top K parameter. Top K means I don't care about the probability. I just top K is 2. I take the first highest 2 answer. Even though the second answer probability is very, very low, it is still possible to coming out. Okay? It gives you a case of randomness to give you another answer. But top K is not good enough in general. You want to sort your probability by order and then use something like probability distribution, 50%, 20% to rank it and then pick the answer. So how does the LLM to get the next keyword is follow this logic. Temperature first, flatten it, shrink the height of the distribution, and then pick the top K, a list of probability, a list of candidates, and then another filter, top P, and then true probability. Some model will reverse the order, but it's very similar. You don't have to care about it. And then got the final answer for you. Okay? No other those parameters. And when you select or use LLM to do something, do remember there's some limitation. One of the very important limitations is about the token. Okay? Since people say that this model is very powerful, how is it powerful? Always say token. It is let you to have longer input and longer output. And it can help you to solve or complicate problem in general with more token. But token means money. Okay? You can't always set the maximum token. You need to cost a lot of money and also very slow. Okay? And another thing you need to remember is the weight limit. Nearly all the API bases or even though you host a LLM, it's very heavy loading. And if you do something really serious or data processing, you will always run the range limit will be researched, and then you need to take care about the range limit always needed. And for safety, for Amazon and also every current have the protection. This is very different. You host a model yourself and or use a car render. The car render will tell you if you want to ask something full language, okay, and then it will block it. But if you host a model your own, it will never block anything. Whatever it will answer. Okay, and now we come to the prompt impact. What does it cover? Something functional, just explain something very simple. We will not spend a long time. But you need to understand structure. The structure is already instruction to the summary and provide the context, it means the background information. And then the output you expect it will send you output. But here it's not an output instruction, just an output. It is auto-complete. And this one is something very interesting. Yeah. Sometimes you seem to remove it. Never mind, just skip it. This is something very interesting. If you have some problem on your LLM, you can always put this sentence. This is very useful. If you're unsure, don't answer. Okay? Otherwise, you will always hit this problem, so-called hallucination. What is hallucination? It's so simple. You ask a very simple question. Your father is you so-called China. What is your mother's last name? Logically, in Chinese, you don't know. But if you ask the LLM, it will always give you the answer. See, this is the probability. Even though the probability near 0, It is also improbability. It will always give you the wrong answer. So people, if you ask something, this is a basic prompt engineer, always put it last. If you're unsure, just tell me you don't know. Then the LLM, if the probability is really very low, logically not working, it will provide you correct answer. I don't know. This is the correct answer. Okay? And this is so-called classification. And you look at the training, you just ask the question of tell me positive, negative, done. You tell me this is different type of document, done. Just tell me as it have the data again. And also, this is very useful. When you do the prompt engineering, you want to scope down filtering as the LLM know everything. You want it to answer something in your question, in your scope. For example, when you are AI assistant, you just answer me something according to the scientist and technical. Otherwise, if you try to answer, you follow all kinds of possibilities. For example, you ask entropy, maybe economic, maybe chemistry, maybe physics, everything with equilibrium, entropy. It will give you wrong answer. So you just set the role play. You are something. You are a teacher. You are a physics teacher. You are a chemical teacher. And the answer will be scoped up, filtered. And the code generation is so simple. You just say, oh, I remember you. Normally, most LLM can do it. And then some fine-tune programming, fine-tune the model will be very good at programming. And code generation is good for database. SQL is really good in you can try different types of LLM. But calculation, beware, you can ask a simple calculation reasoning. But complicated method, it will never work. Okay, you do remember that there is no AI. There's an autocomplete. Okay, everything autocomplete, no AI. If this is something never in the internet, it will never able to do it. So it will find the answer. But here is one example. How to make your model, not the LLM, become more smart. Is that, you found the question, just a computer, give me the odd number and then add it together and then is it even or odd? Just ask this question in this step. It gives you the wrong answer. Okay? How to make it work? One keyword. Break the problem into steps. You just put here. The model will become more smart. But if you understand what I said before, this is regressive modeling. Every output you consider the first step to tell you the next step. So you ask it to do it step by step. Then you review what they output and then generate the step with the step 1 and then generate step 2. So it will give you the logical explanation. Sometimes you want the answer incorrect, ask it to explain. If they find the answer not explainable, no logic, they will change the answer. This is something very interesting. So don't just start with asking it. Ask for the step. Ask for explanation. Okay, now this is going to the advanced technique, and in Pakistan time I should have 10 minutes at least. And this is something so-called well-known prompt engineering. In short, it's so simple. Just example, you want your large language model to follow you get some output. You need to do the example for it. Then it's something like human. You want to solve the example to your main, and then if they will go to you have to solve the problem. So simple. So don't expect too much. You just give a example here, and then finally get the final autocomplete. If you know what I say, this is not recursive, then and then get the output, and you give you the correct answer. For the similar logic, this is a very so-called check model. You can follow the so-called COP, check or fall. 中文係思路點 You need to bring them to ask the question related to your problem step by step. It will give you the final answer more accurate. This is the logic. And also, on top of COP, people found that if your problem is able to convert into Python, just write the Python to your LLM. It understands Python. So when you solve the problem, you don't just give the example to it. You give the formula in Python to the LLM. And then they read the Python, they generate the Python, and then read the Python, get the answer. They become the Python interpreter and become more powerful. Okay, so Python is their first language in LLM. This is so simple COP is that I told you that just put the line, very step by step, it will change the step and then bring it back, and then some problem will be solved without doing anything. And this is something so self-consistent. This is something not very smart. Just a ruling. When you know that there is some problem is that the model will give you a random answer. You just ask it a few more time and then take the answer more people. Okay, for example, you call 4 times and then 2 of them return true for you. You take the true one. Solve the problem. This is the way people should solve problem. But about money. Okay, with 4 times your money to solve the problem. And it is very similar, so-called knowledge generation problem. If you try to extract the knowledge in the LLM and then let it read it back into their brain to give you the final answer. It is something very similar to GAR. Okay, you just ask the question one by one of equal knowledge, and the final answer will be do the secret requested to read back your conversation. All of the language models don't have memory. Every time you ask the question, it just reads everything of the past. That's the reason why when you ask the language model in another domain or another question, we never clean it up. Otherwise, you corrupt their thinking. Oh, this one go to LangChain, like last 5 minutes, not less than 5 minutes. I think it's very pattern. It's very, very interesting. 中文我哋嘅左右互搏 ，OK， you just make your LLM challenge itself to generate the answer. Nearly at this moment, all of the advances that AI model is on top of this platform. What does it happen? Don't see this one. Yeah, you just this is the prompt. You make the prompt here so that you ask the question. Here's my question. You need to figure out how we take the action. The action has the input parameter. And then the action will come feedback to you. And then you repeat this process until you get the final answer. Okay, this is see the result. This is the prompt. See the result. The result is but here is just install LangChain. And then this is the code. Remember this one is not working. Since I don't have code here, I only have Python. Python is not smart enough to solve this problem. I don't have access to code here at all. But if you use I think code here will work very properly, but this one is another. I ask the question, it's so simple. Anyhow, anyhow, and then just get his current age, okay, current age, and then calculate his current age in power of 0 to 1. You know that this is break the limitation of LLM already. You know the latest data it don't have. Although they can't do complicated mathematical operation. What does I do is that I give 2 agent tools to the LLM full LangChain. One is Google search, second one is Python, and then one is then you solve the problem. Well, first question is, well, you know the LLM, I need to know who is Andy Lau. This is the first action. And then it's up, they say that I have 2 tools here to help me solve the problem. First is Google search. This time I need to ask Google, and then the parameter is Andy Lau. It goes through Google and download the Andy Lau information. And then they read this information and then they track the birthday of Andy Lau and also his background. Okay? And then it asks the question. Okay, I got Andy Lau, and then it's not useful. I need Andy Lau age. Second Google search. And we found, oh, Andy Lau is 61 years old now. And now the last section is solve the problem. They can't do the power 2.0. Okay? Oh, I need to write this Python formula and then write it. And then final answer is based on Python interpreted output to solve the problem. Okay? Oh, today I come here and what was that? Is that, well, do you want to have a very large language model with million tokens? Is it very useful for you? Yes, it can solve everything, but you don't have money to solve it. 10 questions you will battle. This is not making sense. So that's the reason why you should still take time to learn about RAT. RAT is always useful due to money. No other reason. If you put all the data in the LLM, it is already best answer for you, but you don't have so many money. Okay, this is here. And so RAT is fine. And it's very similar. You index data here, and then you have a question in extract from the vector database, and then inject into the prompts, and then get into the final answer. This is reference. And this is something so-called fine tuning of RAT, but does not matter. From my experience, when you want to use an LLM, just check something. If there is something called function call, that's the best. Okay, function calling, that's the best. If the LLM don't have function calling, it will not always return JSON for you. If the LLM can't return JSON for you, you will have a lot of problems. That's what I'm facing for a task from the last year. I try different LLM, but if the LLM able to handle JSON, but if the LLM can't do it, use LangChain. LangChain have the wrapper to help you solve the problem. Well, okay, let's time up. Thank you very much.
Okay, so next we will have the photo taking time. May I invite all the speakers and also volunteers to come out. And Amos actually prepared some souvenirs for all the speakers today.